Yes. Like I said, my name is Justin Lee. I live and work in New York for Squarespace, and I just want to preface this with my video card is kind of on the fritz, and Apple wanted to take it for a week to fix it, but I was coming here and I didn't trust them to get it back to me on time. So sometimes this presentation software freaks out and it reboots, but if it does, I have a spare laptop that we'll just switch to and we'll move on. It won't be quite as fun, but we'll get through it either way. So, right. So who am I? I've been working with Java since '96, and I've been kind of up and down the stack, back and forth. I'm currently at Squarespace, where I'm actually doing more Hadoop-oriented stuff these days than what I used to do. Which I was on the Grizzly and Glassfish team with Sun and then Oracle for a while, where if you know me, it's because I implemented the WebSocket support for Grizzly and Glassfish, and I currently serve on the expert group for that JSR, which I'll be talking about after lunch today, actually. So if you're interested in that JSR, swing on by. I've been working with Java EE since around 2000, give or take. I started on the web side of Java before there were servlets and JSPs, and I've kind of gone through all of that. And at the time, I worked for a company where we actually built our own ORM. It was back in the day where app servers were crazy expensive, which I guess they kind of still are. And my company didn't feel like they wanted to spend the money to actually license an app server, so they paid a bunch of developers to write our own. So I worked on the database layer, which I'm trying to forget as much of that as possible, because it was interesting, but whatever. So Mongo, how many of you have used Mongo? Quite a few of you, perfect. When I went to Squarespace, it was actually my first experience directly with Mongo. I'd been reading blogs and watching this and that, but it was my first one. So the transition from a more kind of JPA, Hibernate-oriented environment to Mongo is a pretty recent one for me. And the transition was easier than I expected, but there were some kind of interesting bumps along the way because you have to do things a little bit differently. But first, for those who haven't used it, we'll go over a little bit about Mongo. It comes from humongous, which I don't know if that translates out of English or not, but humongous is kind of a slang word for big. I would have thought it came from somewhere else, but that's the official line, is it comes from humongous. It's scalable, high performance, open source, NoSQL database, web scale and all that, if you're into such terms. It is written in C++. There are a number of drivers for just about any language you care to use. We'll be looking at the Java driver today, obviously, since this is a Java conference. But it is document-oriented, so instead of rows in a table, we're looking at whole documents. You get out huge chunks of JSON instead of individual little cells out of a table. It is fully indexable using variants of B trees in and out. It supports replication and high availability. It's recommended to always run with replica sets for a number of reasons, and those aren't terribly difficult to set up. You can run MapReduce on it. It has MapReduce built in. Last time 10gen was at our offices, which was before the 2.2 release, they were like, you can use it, but for the moment, use Hadoop. There are some issues, but it's getting better. We haven't looked at it since 2.2 came out, but supports GridFS, kind of around that. I haven't looked at too much at GridFS, but it's in there. So what's it mean, document-oriented? In JPA, you typically have one object mapped across a row. Sometimes that one object might be mapped across multiple tables even, depending on how your object model is set up. In Mongo, it's all one humongous chunk, which has certain benefits. Let's see. You can embed your objects inside your document. So with JPA, typically if you have an embedded object, it either extends your row out with weird stuff that's not necessarily related to your particular entity, but it's kind of tacked onto the end. Or worse, it's done with a join across a different table. And you have to either lazy fetch that or eager fetch that. But with Mongo, it's straight in the document, and we'll see what that looks like later. They're stored in JSON style. It's actually BSON internally, which is binary JSON. which is supposed to be a little bit more space efficient. It's not terribly space efficient because still whenever it stores your document, it repeats the keys over and over and over again. So one of the recommendations for people who are like really space sensitive on the hard drive is to use really short keys. A is a 4, B is a whatever, instead of an actual semantically meaningful term. That gets tedious. So, but that is the BSON spec if you're into file formats. It's not terribly interesting, but some people enjoy that sort of thing. And BSON, they use BSON because it adds a little bit of extra information that they can use to optimize certain operations within the database, indexing and searching and the like. Did I get... I didn't. So this is what a document looks like inside of Mongo. Can everyone read that in the back? It's an image, so I can't scale it too much, but we can try it. And if you've seen JSON, that's exactly what you've got. In this case, you can see we have an embedded object, an array of addresses, which is its own separate document that is directly embedded inside the larger one. This one is the user's collection. Like I said, it does support replication and high availability. It is eventually consistent. So by default in 2.0, I believe whenever you wrote to it, it said, hey, we're good, and returned, even though it hadn't necessarily made it out to the file store. There are things called write concerns where you can specify, I want you to make sure you write to the disk before you tell me the write was successful. And there's other settings where you can say, I want you to write to all the replica sets before you come back. So it depends on how sensitive you are to periodic data loss if your system crashes in the middle of whatever. The default now is fsync write, which means that it will write to the local disk before returning, but not necessarily to any of the replica sets. And that's now the default, which is a little bit nicer. It does support replica sets, which is pretty straightforward to set up. And sharding. Everyone familiar with sharding? It's kind of a new term in this particular whatever, but it's basically, whereas a replica set is an entire copy of your data living on a different machine, what sharding does, because sometimes your data gets too big, it actually takes vertical shards of your data and it moves it across your cluster. So whenever it has to look at data, it might be looking at multiple different machines to find whichever document you're looking for. And that is, you should definitely look at sharding if you're starting with Mongo. 10gen recommends that you wait to shard, because sharding is mostly a one-way street. Once you shard on a particular key, getting it back into one large database, because like, oh, that was the wrong key, and now we're stuck with this shard. Unsharding is fraught with peril. It's apparently doable, and there's documentation on 10gen's site, but they don't really recommend you do so. Let me do this. I scripted this in case it crashed. And this should be there. It'll save us a little bit of time of typing because I didn't quite get the dual monitor thing worked out. All right, so we're going to look at a handful of queries, and then we're going to look just to see kind of what Mongo looks like before we get hide it behind some code. That's not terribly readable, is it? All right, never mind. We'll go straight to the shell. How is that? That's not so bad. All right, I have all my queries scripted for me. All right, so this first query looks like that. Now, DB, all the, of course, it's hidden behind the thing. All right, can you read that? So DB, it's database, and then dot and product orders is the collection. I'm not sure where my data went. We might have to do images after all. So product orders is the collection. Instead of tables, Mongo talks about collections, and there are just collections of documents. And it is actually schemaless, so you could have multiple different types of documents inside one collection. It might make sense for some people to do that, but typically collections tend to be homogeneous because otherwise it makes it difficult to do things. Let me see. Oh, I know what it is. I'm in the wrong database. I don't know why it keeps going to this other database. I actually delete it, and when I come back in, it tries to load that thing again. Okay, so that is what a document looks like. Let me do a do a limit of 1. Make it a little easier to see without all the clutter. Okay, so there's the query. So it's database.collection, and then in this case we're calling the function find. And inside the parentheses you'll see the query syntax, and it is literally just a JSON-ish document. I say JSON-ish because there are certain syntaxes that this supports that's not technically JSON, but if you know JSON, the query language is not going to be all that difficult. But it does lead to some awkward queries that we'll see. If you're coming from a SQL world, it kind of inverts some of the operators, and it's a little weird to work with, but you get used to it. So this one is pretty simple. The IDs, typically IDs are object IDs, which are very nice. They are globally unique in a number of very special ways. In this case, it stores class name, which we'll see here in a minute, and then there's some various metadata. This one has products inside it, an array of products. And let's see a multi-clause query. Oh, and I should mention, you notice that I said .pretty on the end of it, and if you don't, it ends up looking like that, which is not bad, but it's a little more difficult to read than if you do that. And pretty much any query you can add .pretty on the end of it, and it formats in a nice way. In this case, we're doing 2 search criteria. One where the order is fulfilled, it's true, and there are at least 3 items in the size. And size is weird, and we'll take a look at it here in a minute. That's not what I wanted. Sure. That is probably true. Limits are weird, a little weird in Mongo. I think it'll do the full fetch on the collection on whatever your criteria is, and then only return back a certain limit. I'm not 100% sure that that's true, but I know that there's a little bit of hand waving in the documentation about limit inside Mongo. But it's pretty fast. Mongo actually prefers to have everything in memory. Because of how it's built, it prefers to have everything in memory. So for example, on our servers at Squarespace, we have a number of different machines, and they all have 96 gig of RAM on them, so that our entire data set can live in RAM. So it may fetch the entire thing back, but it's in memory, so it's not as big a cost as you might expect, but certainly it's bigger than you would probably want in some cases. Anything else? Okay. And the next query I wanted to look at, this is a little bit more involved. Let me change this back to a 1. Display a little bit better. In this case, we're going to go find all the products, all the orders with a certain product in it. And in this case, you'll notice that products is an array of product classes. So we're going to look for products.name. And in this case, if you notice the last query, if I can duck out of the way, you'll see like fulfilled is just a string. Size is just there out in the open. There's no quotes on it. But in this case, when we're searching for the nested object, if you don't have those quotes around it, Mongo will freak out when it sees the dot in the product.name. So that's what it's for. Now in this case, we're looking for any orders with any of, in this case, 2 different products. The names are meaningless. I actually found a website that generated like as many random products as you wanted. So you'll see some rather weird names. They don't mean anything. They're just randomly generated. So in this case, we're looking for Quadtech and Biolux. And as you can see there, we have a product with those 2 items plus another. And that's what an in query looks like. Now, when you do an in query, like most SQL databases, you're almost certainly bypassing the index. So you want to be careful with those types of queries because those can get really expensive because you'll end up doing full collection scans. Sorry, ever since I got here, I've been really dry, which is weird because we're right by a whole bunch of water, but that's how it works out. That's the same basic query, so I'm gonna skip that one because this one is ultimately more interesting. And that didn't take. Give me an OR query. Most of the operations that if you want to run a function, it's like calling a method and passing parameters, basically. So all the built-in functions have $signs in front of them. So you have ORs and ANDs and INs and not equal and greater than, which is GT. It can get rather terse depending on what you're running. So in this case, we're looking for every order that has 3 items in it or it has not been fulfilled. And in this case, it returns a grand total of 1, which actually is the same order that we saw in a couple of other queries. So that's the queries can get a lot more complicated, but I try not to do those in the Mongo shell because it does get kind of ugly. All right. Updates. Updates can get pretty funky, but we will, in this case, before I run it, I don't know if you can see it or not, we're going to update every order that has a size of 3, so every order has 3 items. We are going to change the price to 400. And then let me do something for you real quick, just to so we can see it in action. This will take just a moment. While that's running, I will say this is actually all up on GitHub. All the code, all the samples, the presentations, all on GitHub. I'll have the link for you later. But I'm actually using testng right now to push a whole bunch of data into the database, so we can take a look at it. Mongo focus. Okay, so let's find the size 3 orders just for reference. Okay, so as you can see there, the price is not quite 25,000, or the total, not quite 25,000. Again, randomly generated, but. And then we're going to update this order because it has a size of 3, and we're going to change the total to 400. And as you can see, there it updates. The update syntax is actually kind of weird. When I was first learning it, I would try to update things, and I would end up with a collection, or with a document that had only the updated value. Everything else was gone. So do be careful when you're learning, because apparently it doesn't take a whole lot to fat finger that particular update. So that's what an update looks like. Now this is an interesting thing that I learned while trying to figure out some interesting things to show you. Sometimes you're not wanting to change items on a document. Sometimes you want to add things to it. So in this case, what we're going to do is for everyone who has ordered 3 items, we are going to reward them with a special bauble. I don't know, does the term bauble mean anything to you? I don't know if it translates or not. It's just kind of a random, like, hey, here's a little toy. So in this case, as you can see, up top, we just have products, everything we've kind of seen so far, it's fulfilled. But we're going to push a sub-document into the document we're looking at. And then if we take a look at it again, you'll see now that this order includes a red bauble. And that's how you can push documents into if you need to from the shell. And that's actually kind of a handy little addition in case you forgot to add things to your model when you're writing stuff out. And that's just a repeat. I have, because my laptop kept freaking out on me, I actually scripted it, so you have kind of all these screenshots included, and that's also on GitHub in case people want to take a look at it. But we're done with those, so we'll go back to the non-scripted version, which I think actually says, we're going to go look at code now. So there's a number of things I want to look at with the code. I want to look at the model objects just so we can compare and contrast what a JPA model might look like in Mongo. I'm not going to call these best practice models. If you're looking at a database, I was actually just looking for a couple of different scenarios where you might do. So I'm not suggesting this as the best model for an e-commerce store, but it shows the things I wanted to show. So with an address, as you can see, it's pretty simple. Has an ID, streets. It's little US-centric addresses, but I didn't know enough about Swedish addresses to not really make a mess of it. Product, name, ID, price. It's a double because it was just simpler that way. Bad for money, I know. Product order. So we have an order date. We have the user who ordered it, which we don't do a whole lot with in this particular code, but it's there. We have the list of products. We have an address, and of course the Boolean whether or not it's fulfilled. Pretty basic model, and here's the user. Now, with JPA, we can do things like this, where we have a list of product, and we can trust JPA to fetch it in depending on what your implementation is, either lazily or eagerly, and it just shows up like it's there. There are no foreign keys as such in Mongo, so anytime you want two sets of objects like that, it either needs to be in one document or you have to do multiple queries to fetch things out. And we end up doing a little bit of both at Squarespace because it depends on how you model what your data is and what's important to get at the same time. So before we go to the queries, we'll take a look at the Mongo model, if I can find it. I have all these DAO on model directories betraying my JPA history. So address, it actually looks pretty much the same. In this case, I extended a JFocus entity because it was simpler. And you'll see that they all extend this. And essentially, it just defines the object ID and some basic lookup methods that I use from time to time in some of the test code that you'll see. Again, object ID is one of the greatest objects I've ever found. It's actually really nice if you want a unique ID. A lot of people use UUID, which can be terribly expensive. Computationally, object ID gives you this similar distribution and uniqueness without some of the cost of generating a UUID. And it's timestamp based too, so if you have a bunch of IDs, you can actually order by object ID, and you'll actually get them in chronological order that they were created, because one of the biggest components, there's a machine component and a timestamp component. So they order nicely if you care about ordering of IDs. Product looks pretty much the same, double price. Where the biggest difference you'll see is product order. And again, we see the list of products. But what's different than when we look at the JPA data I used PostgreSQL in the demo code, but it ends up being two different tables, and then JPA will lazy fetch the products in. But as we saw earlier, in Mongo, it's actually all one document, which if you do lazy fetching, it's almost always worth it to stick it in the same document because it gives you the same behavior characteristics. The code's not all that terribly different, but there are some. When we look at the queries, we'll see a little bit of the differences. Let's come back to that. Okay, so just for grins, let's look at some queries. That is for when I test, I delete all the data and put it back. So deleting an order, we go in. My JPA was a bit rusty and Hibernate was complaining, so I went through and did some weird things with deleting an order. It didn't want to cascade my delete for me, so I had to go through and set all the ones to null. So the delete is not quite what I'm sure it's supposed to be. But for these queries, to find a user, it's pretty basic JPA stuff. If you're familiar with JPA, none of that should look terribly exotic to you. So there's find user, find product. Those are pretty basic. Now, where it got really entertaining for me was when you want to do interesting queries. And that's usually where query languages start to trip themselves up, because they're great general things, but once you try to get very specific, it can get very, very awkward. And that's where we'll start to see a lot of divergence between how it's done in JPA and done with Morhpia. And we'll look at a number of different Morhpia queries. But in this case, I wanted to find all the orders over a certain price. And it's not terribly difficult to write in JPA once you remember that there is a having keyword, which I had to have my brother remind me when I was trying to write this query. So if you're familiar with having, the query is not terribly difficult. We're going to go find all the products, or all the orders. We're going to join the products table, and we're going to group by all the orders that have a sum of all the prices over a certain total, and then order it by the price. Order by the sum of the prices. So it's a little complicated, but not too bad if you've done a lot of JPA. It's the same basic query. We're looking for all the small orders, so anything under a certain count of orders, we're going to go find. Again, we're going to group by, we're going to having. Awkward but doable. SQL does that kind of thing. I added a find by hair color. If you'll notice, when we looked at user, do I still have it? There is no hair color in user. So this code actually compiles with this query. If I can go back to where did I see it? The DAO. IDEA actually complains for me. It can see that the hair color property does not exist. But the code will compile. It'll fail at runtime because when it goes to query that particular column in the database, it'll go, huh? But it compiles, which is an important point that I want to bring up later. I just have it here for comparison. Now, in Mongo, you have a couple of options about how to query. There is the Mongo Java driver, which in my current project, when we're doing some Hadoop analysis and we're doing all of our analysis in Hadoop and we're pushing to Mongo, we actually use the Mongo driver directly because it's simpler in a number of ways. There's also a project called Morhpia, which is awesomely JPA-like. It made the transition from JPA to Mongo pretty smooth. There are some obvious differences because modeling and queries and whatnot, but we'll look at Morhpia, and that's very nice. There's also one called Jongo, which is a relatively new project. I think it's just the one guy working on it. But the nice thing about Jongo is it does map into your objects like Morhpia does, but it actually tries to use the exact same syntax as you would the Mongo shell. So if you really love the Mongo shell query syntax, Jongo is awesome because you can literally cut and paste and it just works and it'll map up into your objects for you. So there's Morhpia, Mongo, and we're going to look briefly at one, and I don't want to toot my own horn too much, but I like to fiddle, so I wrote a project called Critter. One of the things I don't like about some of these mapping layers is that it's all string-based, and in Mongo, if your schema changes, it's not a big deal. If you query by hair color on the user table in Mongo, it'll just return you nothing. It's like, well, I don't see a hair color, so I'm going to give you a whole lot of nothing. And it won't give you an error. It's like, okay, I don't see it. And that's not necessarily what you always want. You want to know that your model changed, now your queries are broken, rather than just getting back empty documents, because Mongo just doesn't care. There's no schema to validate it against. So in the code, all your queries end up being strings as well because they're just properties on a JSON object you're querying. But it's annoying to me when the model changes and I can't tell what all my queries I just broke by I fixed a case on a property and now things don't work correctly. So I wrote one called Critter. It's a little experimental and it breaks in some interesting ways. But it actually generates a criteria object based upon your model object, and you use Critter's methods to build out your query. And when your model changes, your code changes. The generated code from Critter changes, so your code will actually stop compiling if you change your model in some incompatible way, which can be nice and it can be frustrating, so it depends on kind of what you want to do. But we'll take a brief look at Critter and we'll kind of move on. So saving an entity, coming from the code back into Mongo. In this case, I check for, if it's a product, we do something special, and we'll see why in a minute. Otherwise, we'll just pass it to the data store that comes from Morhpia, and we'll say, hey, here's an entity, save it. To create an object, this is just a basic method to create. In this case, we're serializing it to a map. This is using the Java driver, which is why there's so much code to it. It's nice because it's kind of bare metal for Mongo, but it takes a little bit of work. So we have to, in this case, take our product object and have to create a map out of it. In the case of product, there's 3 properties, so it's not terribly complicated. You build a map and you hand it off. and then you pass that map to the basic DB object from Mongo Java driver, and it deals with dumping it into JSON, because JSON objects are basically just big maps anyways. In this case, if there's no ID the first time we do it, we give it one. Otherwise, you'll never see your object again. And then we return it. So some of this is more infrastructure code from some of the other things. Because we don't have a mapping layer with your objects, if you're looking to get information out of it, you have to know ahead of time this object goes in this collection. In this case, I'm cheating a little bit with the Mongo Java driver, that I'm still using the Morhpia annotation to determine which collection an object maps to. You probably wouldn't do that if you choose to go to the Mongo driver, because why would you have Morhpia in your class path if you're not going to use it? In this case, it just made the code a little simpler to deal with without getting bogged down and everything. But the Mongo driver does expose you to things like you can drop your entire database. And there is very little security or authentication involved in Mongo by default, so trust your developers not to do that in production, because it is really that simple to blow away all your data. All right, so to find, this actually is a Morhpia query. Make sure that's high enough. Can everyone read that? I bumped the font up, but in this case, we're creating a query with the product class, and this is Morhpia working, and we're going to look for everything that has the name of whatever string we're passing in. And as I mentioned, name is just it's just a string, so hopefully there is a name on that particular document. We could put an address there and pass in a field name, and Morhpia will just happily pass it along and return back nothing. So that is a little bit of a downside. Now what's interesting, where it got really, really interesting and frustrating, was when I tried to port over the method findOrdersOver. Mongo does not have having clause. I'm not entirely sure why. I'm sure it's a good technical reason. So it actually, I had to alter the model just a little bit. If we look at, this is the JPA version, and you'll notice all we have is we just have a list of products. We have an address, we have fulfilled, nothing terribly complicated. But if you look at product order in Mongo, we have a couple of new fields. We have a total field and we have a size field. Mongo was also rather coy about letting me say, go find me all these objects where the product size is greater than or less than or whatever. It was terribly difficult to get that working. So I ended up actually having to put that data on the model, and we actually do that a lot in our Squarespace model as well. As a traditionally relational guy, it kind of rubs me the wrong way because we're duplicating data where we don't really need to be, and then you have to make sure you keep all that in sync. But NoSQL is all about data denormalization, right? So I guess it's just part of the game. But I did have to end up adding the size to the model so that in my query, then, it doesn't get terribly difficult. We're going to create a query with product order, where the total is greater than or equal to, and we're going to order by the total. Now notice here on, what line is that, 86, we're doing a filter instead of a field, which lets you give a field name and then, oh, I'm sorry, 78, there's two methods that are basically kind of the same. You can put in the field name and then the operation, greater than, equal to, less than. There's not in, nin, if you want to use that particular whatever. And then it just takes an object. Whatever, that total there is an object field. So it can be an array, it can be a list, it can be kind of whatever. So there is not a whole lot of type checking going on there. But Mongo is schemaless, so it doesn't really have a lot to check against. And so that's how we find products over. The query is actually simpler in Mongo. It's just your model is slightly more complicated to get at that data. And you see something similar with find orders over with jongo, just to compare. In this case, as you can see, Jongo is obviously a Jongo class. We're going to get the collection product orders, which is just, I believe, just a string. Yep, string for the collection name. And then we're going to call find, and we're going to pass in the query where it's greater than. The pound is a placeholder, so you can parameterize your queries, and we're going to pass total. And as you'll notice, that query looks exactly, except for the pound, or the hash, depending on, I guess, what part of the world you're from. Looks exactly like what you would write in the Mongo shell. And that can be terribly helpful if you really like that and you don't want to bother trying to learn Morhpia's sometimes arcane way of constructing queries. And then you can see both of them side by side just for comparison. So Jongo is actually pretty nice, but it suffers the same problem. I have a Mongo client that I'm working on. It's also a little experimental, but I like it better than working in the shell because if scrolling is a problem in the shell. But Jongo suffers a problem that it expects your query to be JSON. And in Mongo, you can actually do regular expression queries. So it'd be like the like clause in a SQL database, but instead of it would be db dot whatever. I'll scroll up here in a minute. I know it's at the bottom of the screen for you, but I can't type up there. We're going to find, and we're going to where the name is like that. It actually needs to be, because it needs to be a JSON document, remember. So that's a valid query, and it's a regular expression. So you're going to find all the whatevers with the name that have that in it. And that query works, but it's not JSON, because JSON doesn't expect to see those slashes in it. So Jongo just passes your query into, I think it actually uses Jackson. I know that's what I ended up using because Jackson is very nice. But it doesn't like that query because the slash is not valid JSON. So if you use that query, Jongo is going to break on you there. But otherwise, it's pretty nice. So let's look at Critter very briefly. I don't think I do a whole lot with it because they're more interesting things. But in this case, you can see we're going to create the product order criteria, which is a generated class. It's a little ugly, but it is generated. But it uses the Morhpia API pretty heavily, and it encapsulates most of the things. So in this case, we're looking at we're looking for the total, and as you can see, it's an actual method call. So if we rename the method total, the generated code would change, and this method would no longer exist. So your project would fail to compile. And then internally in total, what happens is you can see it's creating, this is a Morhpia class. Internally, you don't see it a whole lot because you're dealing with the query object, but it deals with creating all the internal stuff, and it passes in all the strings. So all the string-based stuff is kind of hidden away from you, and you get this nice compile safe criteria. And then greater than or equal, which is a Morhpia method, and you pass in the total. So this, as you can see, is as type safe as I could make it in this particular instance. And it works for the most part. There's some weird model things. You can do embedded objects in Morhpia, and when you throw in the @embedded annotation, Critter freaks out because I haven't fixed that part yet. Like I said, Critter is experimental. If you want to try it and use it, awesome. Let me know how it works. I can't guarantee you that'll work for complex models, but I'm getting it there. Anyways, enough of that. That's Critter. Although I do want to do, since I spent so much time on it, as you'll notice with Critter, now this actually failed to compile because a user has no hair color. And this is actually why I wrote Critter, because at Squarespace we have very large models and just strings everywhere. And every once in a while we'll think, we should change this because it wasn't modeled correctly. And then we have these queries that we have to go through and hopefully we'll hit before it hits production and make sure that our queries still work. So that's why Critter. All right, what else is interesting? We have find user by email, which again, string. To find a user with a driver. The basic DB object, which is a basic JSON object, DB object is the base interface in the Java driver, and there's a number of subclasses. There's a different one for arrays and whatnot, but that's what you'll spend most of your time with. So to query with the Java driver, we want to create a new basic object with the ID, and we pass it in the particular ID that we're looking for. And we're going to open up a cursor. We're going to get the collection users, and we're going to pass in the query. And the query is literally just find me the user with this ID of this value. And then we're going to iterate across that cursor. And again, if you use the Java driver directly, you're going to have to deal with getting things out of that DB object and into your object. Not terribly complicated. This is a better example than product because users have addresses, which products just had a name and a value. So you actually have to walk down through the entire structure of your DB object. Again, it's not complicated, but if your model, especially early on, models tend to change a lot. And so every time your model changes, you have to go back and change all your serialization and deserialization. And that gets tedious, but it might make sense. Like I said, in the project I'm working on now, all we use is the Java driver because Morhpia is too heavy to bootstrap and whatnot inside of a MapReduce job. But that's what it looks like in the Java driver to deserialize or hydrate, I believe the official term is, objects out of Mongo back into your Java object. And Morhpia takes care of all that for you, as does Jongo. So we iterate through the cursor and then we return it. Now the nice thing is they at least, this cursor does implement closable. So you can use the try with resources that Java 7 offers. And again, just like opening a connection in JDBC, you want to make sure you either do something like this or you do a try finally and close your cursor because they will just hang out until Mongo decides not to give you anymore. To contrast, this is finding a user with Morhpia. It is a one-liner, which is much, much nicer. And in Jongo, it actually ends up looking, let me inline that. It ends up looking pretty much the same in Jongo, so there's not a whole lot of, oh no, actually that is, I didn't end up getting to Jongo. I don't know what that would look like. Well, I'm not going to live code it for you because we're running short. So that's what the query looks like. Java driver, Morhpia, and before we're almost done to 5 minutes. But let me go over some of the Morhpia stuff in a little bit more detail. Morhpia has the entity like it does in JPA. You can do some interesting things with it. Morhpia has Mongo has what are called capped collections, and you can cap those collections on a number of ways. You can do it in the number of documents. You can do it in the actual physical size in bytes of the collection. I'm not sure where that would make sense because you'd end up losing data midstream. But it'll automatically drop things off the back end if you cap your collection for you, and that's very nice. You can specify sometimes if you're going to just do read queries, you can say, I want to read from the non-master replica set. So if you're doing a lot of reads and you're never writing, it's often faster to read from one of the slave replicas, so you're not loading down the master. And again, the concern, that's where you can set like how safe do you want to be whenever you're writing to it, to make sure that Mongo and Morhpia do what you expect before you move on. There's a number of other annotations. I don't know if you can see that on the side. It's a little bit smaller. The embedded entity lets you say, I want to embed this object inside of another one. There are some lifecycle stuff like you would expect in a JPA CDI environment. You can do post loads. You can do post persists, preload, pre-persist, persist, pre-save, and pre-persist. You can do properties. Now, one thing I did want to talk about is, very briefly, is this reference. So if you have a nested object, you can annotate it with @reference. And what Morhpia will do is it won't save that object in your document when it saves it, but it'll save the ID of that into your document. So your model can have nested objects even though your document and Mongo does not necessarily do that. But to use reference, you have to manage the life cycle of that nested object separately. So you have to save that nested object first so that it has an ID, and then you can save the enclosing object, because otherwise it'll freak when it can't find the ID for that guy. Okay, I got the 5-minute sign. There's a ton of things we can always kind of ramble on about, but I want to make sure that I have time for questions in case someone has them, and we can talk about whatever needs to be talked about. Are there any questions? Yes?
I'm not sure I fully understand, but it seems like one driver for using a database like MongoDB is that in the front end you would use JSON anyway if you have a front end. Do you have a case where you sort of deliver JSON directly to the front end from the back end without going through Java objects on the way?
Yes. We have a number of different systems at Squarespace. For the main site, we actually pull things out of Mongo, we put them into Java objects, and we do things, and then we serialize to JSON and go back to the client. So in that case, we do step through the Java objects for a number of reasons. In the Hadoop project I'm working on, we actually use the Mongo driver directly, like I mentioned, because we don't want to do that. So in that case, whenever we query, it's statistical analysis of user traffic and whatnot. So in that case, when we query for, like what's the traffic for this particular page or whatever, we do just pull it out of Mongo, create the JSON object, and we ship that back directly to the client without stepping through the Java object. So you can do both depending on what your particular needs are. A lot of times that might not make sense to do all the work to pull it into a Java object just to hand it off to something like Jackson to send it back as JSON. So it kind of depends what your needs are.
Okay.
Anyone else? No?
I have a related question. Instead of, I saw you before doing updates. Is it common to just, every time you want to store a new version of your document, you just store the entire JSON structure every time and don't care about doing updates of the specific change?
It depends on what you want to do. If you have a lot of business logic, sometimes it makes sense to pull in the object, change it or whatever, and then when you save that, it will save the entire object again, and that is a big monolithic, right? But sometimes you do just want to do an update operation, whether it's updating the price of an order to discount this or do or whatever, to change an email address or delete or whatever. So Morhpia has this interface called update operations that you can do various different operations on it, and they are targeted at much smaller chain sets rather than reading and writing whole documents back. Does that make sense?
Yeah, thanks.
Okay. Sure.
I might not understand what you it seems to me you're having JSON objects and you're converting that to Java objects through JPA mapping, and you use Django and Morhpia language to retrieve the objects. Mm-hmm. Did I get you right?
Mostly. The annotations are actually Morhpia annotations. There's two, if you look at the project, there's actually two modules. There's a JPA module and a Mongo module. Inside the JPA module, that's obviously all JPA annotations, but inside Mongo, it's all Morhpia. So there's no JPA involved on that side. But the annotations look very similar, which is what made the transition for me from JPA into Mongo rather smooth, because Morhpia, I think, was probably inspired by JPA a fair bit.
So Morhpia is the mapping tools or the mapping metadata.
Right. Morhpia is roughly equivalent to what Hibernate would be. And it provides all the annotations and manages all the serialization and deserialization in and out of JSON for you.
Right. Do you use JPA query language to query the objects too?
No, Mongo has its own query language, so you'll have to learn a whole new query language once you move to Mongo.
But now you're having Java data objects. You have to use.
Oh, for JDO?
Yeah.
I'm not sure. I haven't really looked at JDO in some time. Anyone else? Oh,
Do you have anything similar than, for instance, Hive for Mongo?
Hive?
Yeah.
I don't know. The GridFS might be something similar. I'm not terribly familiar with GridFS, and I've only kind of glanced at Hive. We're not using it currently in my project, but it might be something similar.
Did you move from Postgres to MongoDB, or did you just start like a new project with Mongo? Or
At Squarespace?
Yeah.
Well, we have 2 versions right now in production. We have Squarespace 5, which is actually SQL Server, and it was using OJB, I think, as its mapping layer. I'm not terribly familiar with it. By the time I joined, 6 was already underway, and they had already settled on Mongo and Morhpia.
For speed, or why?
I can only speculate because I wasn't in the room for those particular conversations, but I know one of the things that a lot of the developers value is the whole schemaless nature of it, and especially early on. In our specific case with Squarespace 6, it was a pretty dramatic reimagination of the platform, and so early on it makes model evolutions very simple. Because, like once you write to a database and you have all these columns, like, oh, I don't quite like that. Migration of data can be problematic. You have to write all these DDL statements to migrate this and change that. With Mongo, you can forget it. I'm just going to write something different, and it just shows up. So early on, especially, it makes that evolution really, really simple. So it was probably something along those lines. Mongo is really fast. It clusters better than SQL Server. So. Does that make sense?
Yep.
It is officially 9:52.
Yeah, okay, I think we have to break now to
Okay.
To have some coffee and see you later.
Just real quick. I forgot we have these slides. Again, this is all on GitHub. So if you go to the slides should be. Of course, it's not going to show the link on it. I added that presentation link at the very last minute and forgot to do it right. It is on GitHub for those of you who like to take pictures of the screen, because sometimes people don't do it quite right. That's the link up there. It's just Mongo for JPA devs on GitHub. I think I have a better link. Yeah, down here, as you can see with my stuff, this is my GitHub account, and then just get rid of that and put Mongo for JPA devs, and you can see all the code, all the presentations, the whole bit. And I literally pushed it up 20 minutes before the session started. So that.
Excuse me.
Yeah.
Are you on
there.
Twitter? Could you possibly just tweet it?
Yes, absolutely. I will do
Thank
so as soon as we're done here. Yeah, that's my contact information, blog, Twitter. If you have questions, ping me, let me know, and I'll try and answer what I can. So,
Okay, let's give Justin a hand.
Thank you.